Volume of prisms. So remember, a prism is a polyhedron with two parallel congruent faces called bases that are polygons. So these are just examples. This is a pentagonal or a pentagon prism because it's got two pentagons that are parallel and congruent, they're the same size. This is a triangular prism because it's got a triangle and here and there that serve as its bases that are congruent and parallel. So I almost think of it like there was a shape that was flat, then it rises up out of the paper. So it's almost like there was just a pentagon piece of paper lying on the ground, then somehow with just amazing science or magic, they just stretched this into a three-dimensional shape. It just, all of a sudden, it grew straight up. Or same like this, you could think about it as there was a triangle here standing up, then it just got stretched back and became a long triangle. So that's kind of the idea of a prism. Now the volume of a prism is the area of its base times its height. So notice there's a reason they do a capital B right here, because we have before had area equals base times height, like for a parallelogram, and the lowercase b is a length of a base, whereas uppercase B is the area of the base. So make sure you understand that this B represents an area that will change based on what kind of prism we're dealing with. So we'll see that first here. This is a rectangular prism. So this will be considered its base, this front part. And then the back that we can't fully see is also the other base. So the area of a rectangle is length times width. So this is true for all prisms. Now specifically for this prism, since we have a rectangle as the base, we'll put in length times width for the capital B base. So length times width, we'll do 4.2 times 5. And then the height would be 3. That's the distance back that it goes. So the height is 3. So we found the area of this rectangle, that is its base, and then its height going backwards would be 3. So we get 4.2 times 5 times 3, and that gives us 63 cubic centimeters. Now, some of you may be thinking, why in the world did you pick the front and the back to be the base? Why not pick the bottom to be the base? You can. You could absolutely choose it that way. So I want to show you how you get the same thing. Man, that's getting trippy somehow. Man, that's hurt my eyes looking at it. Anyway, weird. We could treat the bottom as the base, because then we would just say the area of the base is 4.2 times 3. Very lower, sorry. Then we multiply by the height, which would be this over here. That's 5. Well, if you notice, we're multiplying by the same numbers either way. So it results in the same answer, 63 cubic centimeters. So you do have flexibility on what you call the bases when it's a rectangle or a cube. So it's okay if you pick a different base than I do. However, for other shapes like triangles, well, there's only 2 triangles here, so there's no choice on the base. It has to be the area of the triangle. So again, the volume of all prisms is the area of the base times the height. In this particular case, since we have a triangle, the area of the base is 1/2 times base times height. Now this height inside here is the height of the triangle. This height out here is the height of the whole prism. So the triangle, they actually listed the base for us up here because remember that the bases are congruent. So if this up here has a base of 8, so does this one down here have a base of 8. So for the area of the base, which is a triangle, we'll do 1/2 times 8 times the height, which is 5. And then we'll multiply that by the height of the prism, which is 13 centimeters. So 1/2 of 8 is 4 times 5 is 20. And 20 times 13 is 260 cubic centimeters. And we will use a cube, or cubed with the units when we're dealing with volume. Because it's three-dimensional, so we end up having to cube the units. Okay, a room air conditioner can cool a room with a volume of 1,600 cubic feet. If a room has a height of 8 feet and a length of 16 feet, what is the maximum width of the room that the air conditioner can cool? If you notice, this is a problem where they have not given us a picture. So I recommend you draw one. Here's our room. It looks happy. Looks like we're living in a cardboard box. But the height is 8 feet, so the height is 8 feet. The length is 16 feet. What we don't know is the width. So to find the volume of this, what we would normally do is we'd say, all right, V equals the area of the base times the height. And this is a rectangle, so we do length times width times height. But let's look. Unlike number 1 and number 2 that we did on the front of the page, they actually gave us the volume. We're not looking for the volume this time. They gave us the volume. So we can plug 1,600 in for V. They gave us the length, it's 16. They gave us the height, it's 8. So we're using the same formula, but this time instead of solving for the volume, we're solving for the width. 16 times 8 is 128. And we'll divide both sides by 128 and find out that the width, the maximum width of this room can be is 12.5 feet. Because otherwise the room would be too big for this air conditioner to be able to cool it well. Okay, last one, find the volume of the ramp. So if any of you ever set up a ramp at your house for a bike or a skateboard, you know, it could look something like this. You got to ramp up to it, and then in this case there's a flat part. I shaped this more like a ramp that you might drive your car or your mower, your riding mower up on top of. Anyway, not important. So similar to when we did composite figures back in chapter 10, section 9, we're going to do these two separately. Just like with composite figures, we said, all right, we'll find the area of each one individually, then add them together at the end. We'll do the same here. We have two different prisms. So we will find the volume of each one individually, and then we'll add them together. So for the rectangular prism, I'm just going to put a little R here so I'm labeling that we're doing the rectangle. You don't have to do that, but I'm just doing it to be clear in the notes. The area of the base, well, if we treat the bottom as this, okay, so this is 3 feet, so this is also 3 feet. So the area of the base would be 10 times 3. Then the height is this right here, the 4 feet. So we get that that is 120 cubic feet. Then we got to do the volume of the triangular prism. So for that one we do half times the base of the triangle, which is 6, times the height of the triangle, which is 4. That's how we get the area of the base, because it's this triangle right here. Half times base times height. Then we multiply by the height, or it's more like the depth we see for the whole prism, and that's 3 feet. Because like I said, it's almost like this triangle was just standing up, it's just a piece of paper, then it got stretched out towards the back and became 3 dimensions. So our height or our depth is that 3 feet right there. So it'd be 3 feet here, 3 feet here. Half of 6 is 3, 3 times 4 is 12, 12 times 3 is 36. So we get 36 cubic feet. So we have found the volume of each one individually. Now we add them together and get our total of 156 cubic feet.